Have you ever looked at a human and thought, we're kind of weird? We're hairless, fat in all the wrong places, and we walk around on two legs. Compared to our primate cousins, we're downright bizarre. But what if there's a reason for that? What if, for a stretch of evolutionary time, our ancestors didn't just climb trees or run around the savannah, but instead, they swam? They lived a life shaped by water, a semi-aquatic ape. It sounds outrageous, like something from a fringe documentary or a late-night internet rabbit hole. But this idea, known as the Aquatic Ape Hypothesis, has intrigued scientists, writers, and curious minds for decades. It suggests that traits like our breath control, upright posture, body fat, and smooth skin didn't just evolve on land but may have been sculpted by water. So where does this strange idea come from, and why is it so prevalent?
To understand, we need to go back to the very beginning of one of evolution's most controversial detours.
All the way back in 1942, German pathologist Max Westenhofer proposed that human traits such as hairlessness, webbed fingers, and subcutaneous fat might stem from an aquatic phase in our evolution. His ideas were largely based on outdated beliefs, and he would eventually abandon them, though he did lay the groundwork for what would be known as the Aquatic Ape Hypothesis. Independently, Alistair Hardy, a marine biologist, would come up with a similar idea in 1960. His idea was that early human ancestors may have been adapted to coastal life foraging in shallow waters. Hardy suggested that some features of the human body might make more sense if we had gone through an aquatic phase. But to be clear, he wasn't claiming we were mermaids. More accurately, he hypothesized that we may have gone through an otter-like phase. In Hardy 1960, he said, "My thesis is that a branch of this primitive ape stock was forced by competition from life in the trees to feed on the seashores, and to hunt for food, shellfish, and sea urchins in the shallow waters off the coast. I suppose that they were forced into the water just as we have seen in so many other groups of terrestrial animals. I am imagining this happening in warmer parts of the world, in the tropical seas where man could stand being in the water for relatively long periods, that is, several hours at a stretch." He further argued that a variety of human traits were best explained by this semi-aquatic lifestyle. We shed our fur to reduce drag in the water, just like dolphins and hippopotamus. We gained a layer of subcutaneous fat to insulate us against cold aquatic environments. Our bipedalism developed from standing upright in waist-deep water. Our ability to hold our breath, something virtually absent in other primates, evolved not for speech but for diving. Even our descended larynx has been cited as an aquatic adaptation. Human infants automatically hold their breath underwater and can swim to some extent. This is claimed as a whisper of our aquatic ancestry. After all, this reflex also appears in seals and otters, but not other primates. Proponents also point to anatomical details such as the downward position of our nostrils. Even the whites of our eyes, visible sclera, rarely seen in other primates, have been linked by Morgan and others to underwater hunting, suggesting that being able to follow the gaze of others helped us track fish or prey in murky conditions. The use of stone tools was also hypothesized from using rocks to crack open shellfish. This group of ideas make up the Aquatic Ape Hypothesis, or alternatively, the waterside hypothesis. I want to make clear that these are hypotheses, not theories. A hypothesis is an idea based on limited evidence that needs more testing, while a theory is a well-supported explanation backed by strong evidence and widely accepted in science. Though unlike the Neanderthal predation hypothesis, the Aquatic Ape Hypothesis actually had enough evidence to be seriously discussed by some researchers. These ideas were overlooked by the scientific community until they were popularized by zoologist Desmond Morris and later championed by writer Elaine Morgan. In a series of books beginning with The Descent of Woman, she challenged the male-dominated savanna narrative and proposed that many of our oddities, hairlessness, breath control, fat distribution, and bipedalism, point not to dry land, but to the shore. Morgan summed up her take on the hypothesis in 2011. Waterside hypotheses of human evolution assert that selection from wading, swimming, and diving and procurement of food from aquatic habitats have significantly affected the evolution of the lineage leading to Homo sapiens, as distinct from that leading to Pan. Personally, I first heard about the hypothesis in the 2011 series, Mermaids, the Body Found. This show tells the story of a supposedly scientific team's investigation to uncover the source of mysterious underwater recordings and an unidentified body. Notably, the show also strongly presents the Aquatic Ape Hypothesis to support the existence of mermaids. These were dramatic, almost monster-like apes that were foraging on the shore for millions of years. In the show, these apes continued to adapt to an aquatic lifestyle, eventually becoming veritable mermaids. I remember being fascinated by the show at the time, as I was only a kid and this was probably some of the first human evolution content I came across. In reality, this program is entirely science fiction. The scientists were all paid actors, and no, a mermaid body was not found. Talk about clickbait. To be clear, this silly dramatized documentary should not be a stain on the Aquatic Ape Hypothesis. The actual hypothesis never claimed that mermaids existed, and it should almost more accurately be called the semi-aquatic ape hypothesis. Basically, the idea being at some point in our evolutionary history, we were hippo or otter-like apes, and later developed terrestrially. This is a legitimately plausible idea, and it pulls from anatomy, physiology, behavior, and even developmental biology. On the surface, it's coherent, it's compelling, and neat. But now let's skeptically look into the aquatic ape hypothesis and separate fact from fiction. Firstly, let's start with the claim that bipedalism evolved from wading in shallow water. Bipedalism first evolved possibly over 7 million years ago, with Sahelanthropus chilensis being our first evidence. The position of its foramen magnum suggests that it may have had an upright posture. A million years later, we have the fossil of Auroran tugenensis, which had a femur adapted to upright walking. Later, around 4 million years ago, with the appearance of Ardipithecus and Australopithecus, full bipedalism appears. Their feet and hips were adapted to walking upright, though their gait may have looked awkward to us. The Laetoli footprints dating to 3.6 million years ago prove that our ancestors were walking on dry land at this time. Species like Australopithecus afarensis, Homo habilis, and Homo erectus are found in terrestrial deposits. Their environments are well studied, consisting of mixed woodland, grasslands, but also lakes and rivers. After all, we need to drink water just like any other animal. Our bones and our ancestors' bones also do not show any sign of aquatic specialization. Aquatic ape hypothesis proponents sometimes claim that our long legs and slender waists are streamlined for swimming. In reality, our bodies are relatively lanky to dissipate heat. Populations living in warm environments, especially in Africa, can be extremely long and skinny to better dissipate heat, while populations adapted to cold environments have much shorter limbs and stockier bodies. Furthermore, nothing about our bones is necessarily adapted to swimming. No flattened femurs for paddling, no dense bones to counteract buoyancy like those seen in otters or dugongs. Our feet and our ancestors' feet were adapted to walking and running on hard surfaces. Our hands are also no more webbed than any other primate, despite some claiming the contrary. Yes, some individuals are born with syndactyl, where the toes or fingers do not separate well in the womb, but this is a developmental abnormality rather than any kind of adaptation. There is just no evidence that bipedalism or our limbs have anything to do with an aquatic lifestyle. Before we dive deeper, I want to thank today's sponsor, Heroes of History, a free-to-play strategy game that honestly surprised me with how fun it is. You start off in the Stone Age, and as your city evolves, you unlock legendary heroes from both history and mythology. The first 5-star hero I pulled was Leonidas, and I honestly got really excited. I mean, tell me you wouldn't want some of these heroes on your team like Einstein and Hercules. The game mixes city building with real-time hero battles. And what I really like is the strategic depth. It's not just get the strongest guy and win, you actually have to think about team synergy, classes, and timing. Also this feature called Hero Portal where you summon a random hero. It's got this thrill factor like opening up a pack of cards when you're young and trying to get something rare. I'm not gonna lie, it kept me hooked longer than I expected. What made it stand out to me is how it treats history with respect while still being fun. Not just collecting characters, you're collecting achievements, cultures, and stories. It scratches that nerdy itch in the best way possible. If that sounds like your kind of thing, you can download Heroes of History right now using the link in the description. It's free and every download helps support the channel. So check it out on mobile or browser, build your city, and start summoning heroes today. Big thanks to Heroes of History for sponsoring the channel, and now back to the video. Next, let's look at hairlessness in humans. Humans actually have just as many hair follicles as other apes, though our hair is much finer and almost invisible from a distance. We lack truly dense hair everywhere except our heads, which is an interesting topic in itself. Our thin hair is used by proponents of the hypothesis as a comparison to hippos, dolphins, and whales. Our hair was lost to provide less drag in the water, but there are plenty of hairless mammals such as elephants, rhinos, and pigs. These animals are fully terrestrial, and their hairlessness correlates with having a large body size in hot climates. Hairlessness in humans likely evolved as a way to shed heat more effectively, a crucial adaptation for survival in hot, open environments. It also helps to keep parasites off of our body, as they have less places to hide and hang on to. Hair reduction may have began as far back as Australopithecus, but our virtual hairlessness began around 2 million years ago. This transformation is not supported by fossils, but by genetic evidence. One key clue lies in the MC1R gene, which controls skin pigmentation. Between 1.8 and 1.2 million years ago, the dark-skinned variant of this gene underwent strong natural selection. In fur-covered mammals, thick hair protects the skin from harmful UV rays. But once early humans lost their fur, they needed another form of protection, melanin. Dark skin evolved as a natural sunscreen, shielding exposed skin from solar radiation. At the same time, our ability to sweat profusely emerged, forming a powerful cooling system. We have around 3 times the amount of sweat glands as chimpanzees do, and our lack of thick hair allows this sweat to evaporate more efficiently, cooling us. This allowed our ancestors to remain active even in the heat of the day, when other predators like lions need to rest in the shade. This ability also allowed us to persistence hunt, the strategy of running prey to exhaustion. This form of hunting may have been practiced by early humans, but even just being active during the hottest times of the day was a major advantage over other predators. These changes coincide with the rise of Homo erectus, a species that appeared around 1.8 million years ago. These tall, long-legged hominins were physically adapted for endurance. Homo erectus marks the moment our lineage became truly terrestrial, heat-adapted, and predatory. Another point to mention is that aquatic animals can have fur as well. Just look at seals, otters, and beavers. Hairlessness is best explained as a thermoregulatory adaptation, and it only occurred in the past 2 million years. Homo erectus was clearly a fully terrestrial species, making it apparent that our lack of hair appeared unrelated to any supposed aquatic phase. Our subcutaneous fat is another factor that's at the core of the argument for the aquatic ape hypothesis. The argument is that aquatic animals often have a larger proportion of this fat, and it is therefore evidence that in the past we had adapted to that lifestyle. Subcutaneous fat is just fat that is under the skin, and it is important for insulation, protection, energy storage, and hormone production. It is certainly not exclusive to aquatic animals, and other primates have subcutaneous fat, though we do generally carry more than they do. Truly aquatic animals have a continuous blubber layer beneath their skin for insulation and buoyancy, while our fat is mainly located in the abdomen, thighs, buttocks, and arms. Wild primates such as chimpanzees have around 9% body fat, which is quite lean. For reference, most human males have between 10 to 25% body fat, while females have between 18 to 35% body fat. If you look at old photos of hunter-gatherers living a traditional lifestyle, you can see that many had around 10% body fat on average. Just look at this photo of aboriginals. Some of these guys are definitely under 10%, so in the range of chimpanzees. However, in colder climates, more fat is helpful, and in both climates, the fatter the better during hunter-gatherer times. It is interesting how the male beauty ideal often consists of high muscle mass and low body fat. You have to think about what the male standards may have been in prehistory. I could easily imagine the physically largest males being seen as the ideal, though of course that would have varied greatly. The Venus figurines are always fascinating to hypothesize about. They were made for tens of thousands of years in Paleolithic Europe. They could represent the female ideal of the time. After all, large fat stores would have helped a lot for birthing healthy children, and it also would have kept them warm. I could go on for hours about Venus figurines, but getting back on topic, there's nothing necessarily unique about our subcutaneous fat that suggests we must have aquatic roots. Hunter-gatherers carried about the same percentage of fat as other primates, and if they carried more, it was due to success or a need to stay warm. So now let's move on to the next point. Breath control and the diving reflex are often cited as definitive evidence of our aquatic past. In the animal kingdom, voluntary control over the respiratory system is rare and is usually linked with swimming and diving behaviors, control over facial and laryngeal muscles, and also speech. In order for us to speak, we need to be able to hold our breath. Your vocal cords, tongue, and larynx all work together to create speech. Every word is essentially a sculpted breath. Our ability to speak is likely a byproduct of speech development, though it is also possible that it may have been partly due to holding our breath underwater. Humans are able to hold their breath underwater far longer than any other terrestrial animal. The world record is 24 minutes, while fairly skilled divers can hold their breath for anywhere between 2 to 3 minutes. This is quite impressive, though it is only possible with discipline and training. The average person can only hold their breath for between 30 to 90 seconds. which is about how long other mammals can stay submerged. Contrary to popular belief, chimpanzees and orangutans can swim and even dive if they have to,
though chimpanzees generally avoid water due to their dense muscular bodies.
But other primates are truly good swimmers. Crab-eating macaques can wade and even dive for shellfish and plants. They can dive up to 3 feet and be submerged for up to 30 seconds. Crab-eating macaques are also the only old-world monkeys known to use stone tools in daily foraging. They use pebbles to crack oysters, bivalves, and swimming crabs. This is very interesting and could seemingly be used to support the aquatic ape hypothesis. However, there is something important to note. These macaques do pretty much everything the aquatic ape hypothesis suggests. They often forage in aquatic environments, can swim and dive, and use stone tools to access food resources, yet they are full of fur and have normal monkey fat distribution and are not bipedal. The existence of primates that currently live in the exact conditions hypothesized in the aquatic ape hypothesis could equally be used to dispute its legitimacy. Another example we can look to are humans that spend a majority of their time in and around water. The Bajau sea nomads are a fascinating group of people who live in maritime regions of Southeast Asia. They are known for their incredible freediving abilities and semi-nomadic sea-dwelling lifestyle. Traditionally, they live on boats or houses over coastal waters. They spend much of their time fishing and diving for aquatic resources. Children learn to swim before they can walk, and recent research suggests that they may have a physical adaptation to the sea. A 2018 study found that their spleens are up to 50% larger than other populations. Spleens help them store and release oxygen-rich red blood cells, similar to that of diving mammals. They have a distinct version of the PDE10A gene, which is believed to be associated with spleen size. This spleen is what may allow them to dive over 230 feet or 70 meters and hold their breath for over 10 minutes straight. Researchers believe that they may have other traits that may be associated with aquatic adaptations. The Bajau sea nomads are an excellent example of how evolution can work to benefit us in even relatively short periods of time. They likely developed this in only around 1,000 years. Perhaps if you gave them 20,000 years or so, they might have developed webbed fingers and toes. This example is very interesting, though it doesn't necessarily support or dispute the aquatic ape hypothesis. It rather just shows how truly adaptable we can be as a species. Another piece of evidence this hypothesis mentions is the infant dive reflex. Infants have a bradycardic response when submerged in water, consisting of holding their breath, slowing their heart rate, and redirecting blood to the vital organs. This is a real measurable phenomenon in human infants less than 6 months old, though it fades with age. However, this reflex is not unique to humans and is widely known as the mammalian dive reflex. Literally every other mammal has the reflex, meaning it developed millions and millions of years ago and persisted in every mammal. Therefore, it cannot be evidence for an aquatic past. Maybe an aquatic past all the way back in the Devonian or something, but definitely not during the past few million years. Staying on the topic of childbirth, human infants are born with a waxy, cheese-like coating called vernix caseosa. This coating protects the fetus's skin and aids in sliding through the birth canal.
However, this feature is absent in other great apes, but found in seals, beavers, and otters.
For a terrestrial primate, it is indeed very unusual that we have this feature. It may be a leftover adaptation from a time when human ancestors gave birth near or in wet environments, or it has some other useful benefit such as infection prevention. Moving on, some claim that our nostrils facing downwards is evidence of an aquatic past,
though the nostrils of whales face upwards and the nostrils of seals face forward.
If we were truly aquatic at some point, you would think that our nostrils would have to face upwards or at least forwards. No aquatic animal has downward-facing nostrils for a reason. Sometimes salt consumption is used to support the aquatic ape hypothesis. Humans lose a lot of salt when sweating and crying, and proponents of the hypothesis say that our waste of salt may originate at a time when we lived in salt water. The reality is that all animals need salt, and many will travel vast distances to find salt licks. Other primates get salt by eating salty clay, chewing salty bark, or by salt licks. Meat is the main source of sodium for hunter-gatherers, and many groups directly consume blood to get access to its rich electrolytes. Our craving and need for salt can therefore be fulfilled by hunting and scavenging, something we have done for millions of years. Lastly, we should look at the evidence of the diet of early hominins. Surely if they were relying on aquatic resources in the past few million years, That would be a smoking gun for the aquatic ape hypothesis. Through isotope analysis, we can find the chemical signatures of what ancient humans were eating. Dental wear and calculus analysis can also tell us about how the food was being eaten. All the evidence from early hominins suggests a terrestrial-based diet consisting of terrestrial plants such as tubers and terrestrial animals, not fish or mollusks. Though the earliest physical remains of fish or turtles being consumed come from 780,000 years ago in modern Israel, the earliest consumption of seafood comes from 500,000 years ago in Indonesia. This is quite old evidence, don't get me wrong, but these hominins were pretty similar to us. They were the species Homo erectus, and in many ways they looked like us and their anatomy was quite similar. In his critique of the hypothesis, paleontologist Henry Gee emphasized that while humans have been bipedal for around 5 million years, evidence for significant seafood consumption doesn't appear until roughly 200,000 years ago, undermining claims that an aquatic diet drove upright walking and brain development. Seafood consumption only appears to have become common with Neanderthals around the Mediterranean and Homo sapiens in Africa after 200,000 years ago, both species which are clearly fully terrestrial and already had large brains. Some evidence suggests Homo species may have consumed aquatic resources as early as the Pliocene, and the idea that such diets played a pivotal role in brain evolution remains controversial. The last claim we must address of the aquatic ape hypothesis is that the fossil and archaeological records are incomplete, and that is true. But the missing pieces don't support an aquatic past. They don't show coastlines full of diving apes. Instead, they show a gradual adaptation to a wide variety of environments, from savannas to forests. Frankly, the hypothesis is a bit ironic. Throughout much of our evolution, especially in Africa and parts of South and East Asia, waterways were teeming with apex predators, crocodiles. Crocodiles are one of our oldest evolutionary enemies, and they still eat a good amount of people each year. The idea that early hominins would routinely wade or swim through these crocodile-infested waters is hard to square with survival, let alone with the emergence of key traits like bipedalism. Even if you were to say that aquatic apes thrived in areas without crocodiles, there were still other predators like sharks and hazards such as sea snakes. While in northern latitudes, it is too cold for any modern human to spend a significant amount of time in the water year-round. Overall, the aquatic ape hypothesis does not provide a compelling explanation for any of our strange characteristics. There are better hypotheses and theories to explain our rather quirky evolutionary traits. The fossil record also does not support the idea that ancient humans were ever adapted to aquatic life or even the exploitation of aquatic resources until relatively recently, and due to this, it has never really been taken seriously by mainstream anthropology. Anthropologist John Langdon described the hypothesis as an umbrella hypothesis, one that tries to explain a wide range of human features using a single adaptive pressure. The problem, he pointed out, is that these traits evolved at different times and for different reasons. Trying to tie bipedalism, fat distribution, mammalian dive reflex, hair reduction, and more all to the same supposed pressure is sloppy. Anthropologist John Hawkes agreed with this view, noting that the soft tissue traits that the hypothesis claims are uniquely human, such as fat distribution, sweating, and hair, are actually common among primates. Where there are differences, they're typically due to thermoregulation, not aquatic behavior. The fossil record doesn't show diving apes or shoreline settlements. It shows hominins adapting to open woodlands, shifting savannas, and eventually, very terrestrial environments. The aquatic ape hypothesis has been routinely criticized and dismissed by nearly every major figure in anthropology. Paleontologist Henry Gee has compared it to creationism. Paleontologist Riley Black called it a classic case of cherry-picking evidence to fit a conclusion. Anthropologist Eugenie Scott labeled it crank anthropology, alongside Bigfoot and alien-human hybrids. Anatomist and anthropologist John H. Langdon, in his extensive 1997 critique, argued that the hypothesis's status as an umbrella hypothesis made it almost impossible to disprove, and therefore unscientific. He noted that the hypothesis leaned heavily on soft tissue traits, which rarely fossilize and are hard to study in evolutionary terms. The only dataset capable of disproving it, the fossil record, does just that. The traits that the hypothesis tries to explain are either better accounted for by established models, or don't require aquatic explanations at all. Even anthropologists who once flirted with the hypothesis have distanced themselves. Vernon Reynolds, after hosting a 1987 conference on the topic, concluded that while early humans may have used freshwater environments opportunistically, it was unlikely that they were truly aquatic. Philip Tobias declared the savanna hypothesis obsolete, but didn't support the aquatic ape hypothesis either. He saw Morgan's work as interesting, but ultimately speculative. It is clear that the aquatic ape hypothesis simply doesn't hold water. So why do people keep talking about it? Part of it is cultural. For decades, the savanna hypothesis became well known as the mainstream view of our early evolution. It is a strong focus on hunting, aggression, and stereotypical masculine tropes. Elaine Morgan's work reframed the story. Her writing was accessible, her tone defiant, and her framing feminist. She offered a vision of early humanity that emphasized water, gathering, and nurturing over violence and brutality. It resonated, especially with readers who felt excluded from traditional paleoanthropology. Even today, people are drawn to the idea that our past might be more poetic. We didn't just spend millions of years running around on the savannas, but rather slipped into warm lagoons and spent part of our evolutionary journey living a unique lifestyle. And from there, it's fun to speculate about mermaids or other courses of evolution. And come on, everyone loves to go against the mainstream while having their own little pet theory they can bring up in chats at the bar or while out at the lake. The aquatic ape hypothesis is a compelling story. It's just not a scientific one. It isn't pseudoscience in the way that homeopathy or astrology are. It's a hypothesis, and a bold one at that. But being bold doesn't make it accurate. Scientific ideas live or die by their ability to explain the evidence, generate predictions, and survive scrutiny. The aquatic ape hypothesis does not do that. It relies on speculation, ignores contradictory data, and reframes ordinary traits as mysterious anomalies. It's not pseudoscience, it's just not good science. The true story of our evolutionary origins isn't neat or elegant. It is messy, confusing, and we still have a lot to understand about it. No paleoanthropologist would tell you that we understand everything about early evolution and why we have some traits. But the aquatic ape hypothesis has been widely rejected by science and has not received sustained scholarly attention in over a decade. So unfortunately, I would have to tell my elementary school self that the mermaid body found using the aquatic ape hypothesis is unfounded. The rest of the documentary is definitely accurate though. So yeah, the aquatic ape hypothesis is very poorly supported by evidence and, to be honest, is kind of a punchline in anthropology circles. Unlike the Neanderthal predation hypothesis, which I covered a few weeks ago, this hypothesis is actually a scientific one that was debated about and not just conjured up by some Aussie filmmaker. But both of these hypotheses are similar because, they sound cool. They offer sweeping cinematic explanations for who we are and how we got here. And that's why they stick around, because they're stories. But science isn't built on what sounds good. It's built on what works, on testable ideas, on fossil evidence, genetics, and comparative anatomy. And when you weigh the aquatic ape hypothesis against that, it just doesn't hold water. At best, the hypothesis is a creative thought experiment, or speculative evolution. In my opinion, the true story of our evolutionary origins is more exciting, and I hope you tune into more videos about it in the future.
Thanks for sticking around for this deep dive of one of human evolution's most persistent fringe hypotheses. If you enjoyed the video, hit the like button, comment down below, subscribe, and also hit that bell icon so you never miss an upload. Honestly, seeing all those images from the Mermaid Body Found show was like so nostalgic. I remember watching that show, I was probably in like 4th grade or something, I don't remember the year. But I was legitimately sad at one of the scenes because one of the aquatic apes sacrifices themselves so that the megalodon will go after it instead of its friends. And I just remember legitimately thinking that was really sad. So I don't know. Do you guys remember watching that show? I actually think I enjoyed it a lot because it was human evolution and fringe, and it had a body found lost tapes kind of angle. I can see why it was one of the most popular shows at the time. Those images of those mermaids and those apes on the beach are still burned into my mind. And all this fringe hypothesis talk has me thinking, maybe we should make our own fringe hypothesis as, sort of a meme for the channel. But it has to be something kind of reasonable, but also, so out there. But you could tell it to someone at a bar, and just because they're drinking, they might be like, wow, that actually makes a lot of sense or something. We really got to appeal to people who don't necessarily think too much about these topics. So yeah, come up with some fringe hypotheses and comment them down below. And then maybe we'll start spreading them around the internet, and one day it will live on a Facebook algorithm somewhere. I'm honestly pretty excited for what you guys might come up with. I'll leave my own fringe hypotheses about human evolution or something in the comments down below, and just keep going on from there. All right, catching the next one. Remember, stay skeptical. Don't believe in these silly fad ideas like the Aquatic Ape Hypothesis or the Neanderthal predation hypothesis. They're just kind of silly and they're entertaining and they're a good story, so that's why they sell. Remember, that's what I said in the last one too. It's just super true. So yeah, thanks for watching. Do all that stuff. Comment down below, and I'll see you in the next one. Arrivederci.